So you want to start welding but don't know where to begin? No worries. I'll walk you through the basics from setting up the machine to running your first weld. Now a quick disclaimer, welding can be a dangerous practice if done incorrectly. Intense light, heat and fumes can cause irreversible damage to your skin, eyes and lungs. So it's important to know what you're doing before you start. So if you're unsure, consider about getting some training and guidance. Okay, so you want to weld, but what is welding? Welding is a process that uses heat, often generated by electricity, to join two or more pieces of metal together by melting the materials and allowing them to fuse. In welding, there are a few key terms that you need to know. Arc. This is the electric discharge between the wire and the workpiece that generates the heat needed for welding. Weld pool. The molten metal created by the heat of the arc that fuses the base materials together. Bead, a smooth consistent line of weld metal deposited along the joint. A strong weld means a smooth consistent bead. Spatter, which are small droplets of molten metal flying off the weld pool. It can create a messy work area, so keep an eye on that. Penetration. This refers to how deep the weld goes into the base material. Good penetration ensures a strong and durable weld. Tack weld, a small temporary weld used to hold pieces in place before completing the final weld. Shielding gas. This gas is used to protect the weld from contaminants in the air. Heat affected zone. This is the area of the base material affected by the heat from the welding. It can sometimes alter the material properties and cause distortion. Push-pull. This refers to the direction of the torch while welding. Burn through. When excessive heat causes the base material to melt through, leaving a hole. So in welding, we have a welder, power source, torch, earth clamp, and a spool of wire. The wire spool holds the welding wire that provides a continuous supply of wire from the machine. The gas regulator controls the flow of shielding gas to protect the weld pool from contamination. Our gauge with the small numbers refers to our flow rate or working pressure, and the gauge with the larger number refers to how full our bottle or cylinder is. Now with MIG welding, you can go gasless, but you'll need to purchase the correct wire. But I don't recommend it because with gasless wire, you get poor penetration and you'll have poor welds. The control panel lets you adjust the settings like voltage, wire speed, amperage, and other parameters specified to the welding process. And of course, don't forget your safety equipment, which we'll run through later. This is the Unimig Viper 185, a solid little machine that, like other modern machines, can do MIG, TIG and stick welding. MIG welding uses a continuous wire feed and a shielding gas to create a strong, clean weld. It's ideal for beginners and high-speed production. TIG welding uses a non-consumable tungsten electrode and requires filler material. It provides precise, high-quality welds, especially for thin and delicate materials. Arc welding uses an electric arc to melt a consumable electrode, making it versatile and perfect for heavy-duty applications and outdoor work. But today, we're just focusing on MIG welding because it's the easiest way to get started. These are your voltage and wire speed controls. They control how much your welding penetrates and how fast the wire feeds out. Getting these settings right is the key to getting a clean weld. As a guide, there is a table in most machines and online that will refer to material thickness, volt settings, wire speed, wire thickness, and gas flow rates for your welding application. Inside, we've got the wire feed system. This is where you load your MIG wire, usually 0.8 or 0.9 for general use. The tension here affects how smoothly the wire feeds through the torch. Then of course you have your torch, and your ground clamp. This needs to be set up properly for a solid electrical connection. Typically for MIG welding, we use a gas, which is an argon and CO2 mixture. Before getting started, let's talk safety. Welding can cause burns, blindness, and damage to your lungs. Therefore, you'll need a welding helmet, heat-resistant gloves, long-sleeve welding jacket, and proper boots. And if you're working indoors or with galvanized metal, you will need a respirator or a fume extractor. You also want a fireproof working surface or welding table to work on, and always have a fire extinguisher nearby just in case. All right, let's get things up and running. So to set the wire up, we first load the spool into the machine. Then carefully undo the wire, being very cautious not to let it unravel, and then trim it, and then feed it in through the wire feed, which can be a little bit tricky. Just push it through manually first. So it feeds in, then we bring down the top roller and the wire adjustment tension, and then what we can do is we can feed it through. There's a button inside the machine to feed the wire through. If you're using gas, hook up the regulator and set the flow rate, usually around 12 to 14 litres per minute. A few safety tips. Make sure you're in a well-ventilated area and there's no flammable material nearby, and to be cautious not to touch the welding piece after you finish welding, because it will be hot. Never look at the arc without the helmet, because this could cause eye irritation, which could lead to blindness. And also be cautious when welding painted or coated surfaces, because the fumes are very nasty. The recommended shade setting on your helmet is 11 for MIG welding. Before jumping into your project, always run some test weld on some similar scrap metal. This is where we dial in our settings. I've now set my voltage and my wire speed to my material thickness using the data from the chart as a guide. Before we start welding, there's a few things to consider that are really important. Number one is what we call stick out. Stick out should be between 4 to 6 millimeters above the shroud, and also what we call torch angle. So we come down and we have our torch 90 degrees, and then we roll it over to 70. Now what I also want to do is support myself, make sure I'm nice and steady, then bring my head down so my line of sight is directly to the wire. Now I'm ready to weld. Okay, so now I'm going to do my first tack. I'm in position and I want to squeeze the trigger for 2 counts. 1, 2. Let's have a look at our first tack. If I have a look on the outside, I can see it's a nice circle, but if also look on the inside of the metal, I can see I've got enough penetration. So this is a good first tack. So our settings are good for what we're working with. Okay, so I've just done another tack weld. Let's have a look at this weld and let's see what's happened with it. So there's 2 things here that are very visible. Is one, all the little holes. This is called porosity due to bad gas coverage. But also, if you listen to it, it was spitting a little bit, which means my wire speed was too low. So now we're going to do another test tack, but I'm going to deliberately turn down my wire speed so you can hear the noise the welder makes when there's not enough wire speed. So you can hear that was stalling. So it was telling me that I need more wire speed. So now I'm going to go the opposite. I'm going to have too much wire speed, and I want you to listen to the noise again. So you hear the spitting. So when it sounds like it's spitting, I've got too much wire speed. Now I need to turn that down so it matches where I was before. but also too is I can use these arrows to indicate when both settings are where they need to be. Or again, follow the chart inside, and the noise you want to listen to is the next noise coming up. A nice crisp sizzling noise is what you want. Here we have a few test tacks. So you can see the first one, I consider that one quite good. It's sitting on top, I've got good penetration. This one's sitting high and it's quite small, so it's not hot enough. This one here has a lot of holes. It means my gas wasn't on and it would have very, very poor penetration. This one is perfect. Sitting nice, it's a nice diameter. I'd consider that one quite a good one. Again, porosity, this one's too cold and this one's a bit too hot. So now I'm happy with my settings. I'm gonna run a test bead. So if we come down and have a look, you can see what I've done is I've laid my tacks on top of each other, next to each other, and that forms a weld. The method we're doing is called intermittent welding, which is stop-start, and this method allows me to weld without overheating the workpiece and being able to control the weld easier than continuous welding. Okay, so now I'm going to try to demonstrate a bad weld. So I'm going to turn my volts down and let's see what happens. So if we have a look between this weld and that weld, we can see this weld is sitting higher, which is telling me that I'm not hot enough. So I'd probably have poor penetration with this one, where this weld is nice and flat and it's melted in reasonably well with the base material. All right, so now what I'm going to talk about is the difference between intermittent welding and continuous welding. Intermittent welding allows you a little bit more time to control the weld, where continuous welding, you have to be a little bit more advanced and it's a lot harder to get a nice clean weld from it. But I'm going to demonstrate that right now. So as you can see there, it's a nice flat weld. So regardless what method you use, intermittent or continuous welding, both are suitable for the material you're going to be using on this project. Now all this is just the beginning, because we're just about to put all these skills to the test with the pedal car build. In this build, we're going to need a few different types of weld. Here we have a few examples of butt welds, fillet welds, and lap welds. So as you can see here, I've set up a 90-degree butt weld. I've used my welding table fixtures, the clamps to hold it in position, also with a 90-degree magnet. Okay, so let's weld this up. First I'm going to do 2 tacks, and then I'm going to run an intermittent butt weld. Okay, let's have a look at this weld. It's nice and flat, so I know I've got good penetration. There's not a lot of splatter. It's all good to go. Now I'm just going to have a look at my voltage and my wire speed. As you can see, I'm on 16.2 volts with 5.8 wire speed, and that was adequate for my material that I'm using. Now your machine may vary slightly or differ from this machine, but the settings will always be roughly the same. Okay, let's have a look at this weld. As you can see, I have a fair bit of burn through. The reason why is my volts were too high, my wire speed was incorrect, and I had too much of a gap. So to remedy this, I need to reduce my gap, turn down my volts and my wire speed, and that should be fine. So I have another example of a butt weld, but this time I'm butt welding on 5mm plate. I've turned up my settings, my volts and my wire speed to accommodate my thickness, but on this butt weld, I've allowed a little bit of a gap between each piece to allow for better penetration. Okay, let's have a look at this weld. It's a little bit lumpy, but this was done continuous because I'm on thicker material and I don't need to worry too much about burning through on this one. Okay, let's have a look at this weld. As you can see, it's sitting very high and there was a lot of splatter. The reason because of that was my wire speed was way too high for this weld. Okay, now that I've gone back to welding my thinner material, I've readjusted my volts and my wire speed to suit. So here I have an example of a fillet weld that you'll be doing on this pedal car build project. So what I'm going to do now is I'm going to tack in opposite corners, and then I'm going to practice whether I push or pull the weld. It depends what comes naturally to you. So as you can see with this fillet weld I've just done, this was an intermittent weld, and you can see the little tacks are just stacked on top of each other about halfway, which gives me a nice finish. With this weld also too is I decided to pull it. Now what I always recommend is that you practice your path when you're welding. So if you want to pull it, just draw along there and push it back. See which one feels the most comfortable. I personally always like to pull it towards myself. Gives me a little bit more room when welding. Okay, here I have another example of a joint. On the sides I have a butt weld, and on top I have a fillet weld. Now you've got to keep an eye out because we're welding thick material to thin. I'm going to use my settings for welding the thinner material because I don't want to burn through on the thin stuff. So now I'm going to tack on either side, and then I'm going to do my fillet weld, then lay it over and do the butt weld. Okay, so let's have a look at this weld. The tube that I'm using is goual, so I need to remove the goual first, but you can see a little bit of white powder. That's the goual, and that's the dangerous fumes that you want to avoid. But if you have a look at the weld, you can see I've gone quite good here, but then I slowed down a little bit, which makes the weld a little bit wider. But if I was going to dress this weld, it's still fine and strong. Okay, so here we have an example of a typical lap weld where a piece is sitting on top of another piece. I'm going to weld this at the same setting as the base material, and I'm going to weld this intermittently, and then we'll talk about how I get my spacing. First I'm going to tack. Now the way I get my spacing is it's basically a series of tacks, and I just lay them on top of each other. As you can see, they lay over about halfway. I also count while I'm doing this weld. I squeeze the trigger for a count of 1, 2, 1, 2, 1, 2, 1, 2. The pause in between each tack allows me to see where I'm going and to position my wire for the next weld. So here we have another example of a type of weld you're going to encounter on this project. So this is solid bar. So this is a fillet and a butt weld, and I'm going to increase my volts and my wire speed to accommodate the thicker material. So I'm quite happy. I can see that it's melted in quite well and it should be strong enough. Okay, I've deliberately done a bad weld. You can see it's really sitting on top, so I know it's going to have poor penetration, and just watch how easy this breaks. So you can see the weld sitting on top, and it has resulted in a very poor penetration. Okay, here I have a scenario where I've cut a piece a little bit too short and I have a fairly substantial gap that I need to bridge. Not a problem, I can get this in my welding. So what I'm going to do is going to lay 2 tacks on either end, and then I'm going to weld on top of my weld, which will support the weld, and I should be able to fill this up no problem. Okay, you can see from here I was able to weld that 3mm gap quite easily, but if the gap was any bigger, I would have had to become a little bit more creative to weld it and take a little bit more care. I've just pulled apart my last weld and I considered that I got good penetration, but as you can see, it pulled the base metal away, it didn't break at the weld. Always remember, if you're not satisfied with your weld, you can always grind it back and re-weld it, or just leave it smooth as long as you got good penetration. If you're new to welding, don't be afraid to keep practicing before you start your project. And if you want to make things easier on yourself, a good welding table with clamps, magnets, angles and accessories will make a world of difference for the precision of your end result. Well done if you're following along. Hopefully you've learned a thing or two and you're ready to start building your pedal car.